Well, let's do some review just of factoring. So if we had something like x cubed plus 8x squared plus 15x, would you guys be able to factor that?
Yes.
Maybe. There's two steps here. First step is I'm going to look at each term, so that one, and that one, and say what's common to every one of those. X, right? So I'm going to factor out an x. So I'm going to start by just writing the x that I factored out, then start a bracket, and now write what I have left. So I just took an x out of every one of these terms. So this was x cubed, now it's x squared, now it's x. That x came out, which is 15 now. So I factored out that x. Now this is written in a form that we can factor it again, right? And that's kind of what we're getting at with our factored form, is we're going to rewrite this. So I'm going to rewrite this as x, and then bracket, and x there, and x there. And now, does it need to multiply to 15 or multiply to 8? Two numbers we're looking for. 15, right? Multiply to 15, add to 8. So you guys think of any two numbers that multiply to 15 and add to 8? Could it be 15 and 1?
5 and 3.
5 and 3, yeah. 5 and 3, yeah. They both multiply to 15, add to 8. So this must be 5 and 3. And remember, that could have been 3 and 5, doesn't matter. So, and plus because it's positive 15, positive 8. So there we go. Okay, so that was that little bit of review. Should we do another one of those? Let's keep it like that. And now the next thing, let's say that our equation was y is equal to that, right? And I was asking you, where are the zeros on this thing? So on the graph,
With the x in front.
yeah. In this case, this isn't a quadratic equation like we have, because it would actually end up being like an x cubed in there. This would actually end up looking something like this. But it doesn't matter. Let's say I'm asking, what are my zeros? So I'm asking, what are my x-intercepts? What's like that value, and that value? And the way we can find that is, remember that what's the y value when we're looking at the x-intercept?
0.
0. So all I'm going to do is make y equal to 0. So I'm going to rewrite this with y equal to 0, and then write everything the same. And now, if I want to know where my x-intercepts were, all I got to do is figure out what would x have to be to make it equal to 0. So first off, 0 times anything is what? 0. So what I want to have happen is I want to figure out what would make this equal to 0, what would make this equal to 0, and what would make this equal to 0. And those are going to be my solutions. Those are going to be my x-intercepts. I'm going to have 3 of them, which makes sense, right? I've got 3 of them in my picture. So this one's pretty straightforward. What would that be to be equal to 0? 0. So x here must be 0. What about this one?
-5.
Right, x would have to be equal to -5 to make this equal to 0. This one? Right. Oh, that x minus 5. Let's see. X is equal to -5, and then x is equal to -3. So that's kind of the general concept of why we're doing a factored form, is because we can quite easily see what the x-intercept is going to be. All right. Okay, so this is factored form. So before, maybe I'll write both down. Ax squared plus bx plus c. Okay, so this is going to be our factored form now. So you know, like before we've been dealing with this, where a was just some number, b was some number, and c was some number. We're going to have the same thing, but now a is going to be some number. It would be the same number. And then r is some number, and s is some number. And r and s are going to end up being our x-intercepts. So we want this because it's good for x-intercepts. If we want to just look at it and know what the x-intercepts are. Because right off the bat, for an example, let's say our equation was y is equal to 2 x minus 4 x plus 5. Any idea what the x-intercepts would be on that thing? Right. The x-intercepts are going to be 4 and negative 5. So it's always the opposite of what the symbol is. So right now the symbol is negative on that one. It's positive on that one. So it's the opposite. So that's where it's going to cross the x-axis. So this thing would cross the x-axis at negative 4 and at positive 5. Good. Okay, sorry about that, guys. I made a mistake. Said one thing and did another. So that would be positive 4 and negative 5 for our x values. Just checking to see if you guys were paying attention. Okay. Okay, so now, if the next thing we can do from this is we can figure out what our vertex is. So looking at our just equation like this. So if we had something like, let's say 4 and then 2x minus 3 and then x minus 1. And I said, what was the vertex of this thing? So what you want to do first is figure out what the zeros are. So what my x-intercepts are, same thing. They're called roots sometimes. So what would they be? I'm asking, like, what would this have to be equal to 0? And what would this have to be equal to 0? This one's probably pretty straightforward, right? The one on the right? X would have to be equal to 1, right? To make that equal to 0? This 2x minus 3 might not be as obvious right off the bat.
Because you have to multiply 2 and x.
What we're going to do is actually just make it equal to 0 so we can actually see what it is. So let's go 2x minus 3 and then make it equal to 0. So now we can do a little bit of algebra. So now what I'm going to do is just solve for x in this like mini equation. So I'm going to go add 3 to both sides. Those cancel. So we got plus 3. I've got 2x is equal to 3. And then divide both sides by 2. And then x is equal to 3 over 2. Or 1.5. Same thing. Okay, so those are my two x values there. Oh, I did push record. Good. Okay, then that brings us to, if we want to figure out what our vertex is, let's kind of sketch this out really quickly. So I know that this thing is going to have an x-intercept at 1, and 1.5. So it's gonna be, and I know it's opening upward too, right? How do I know that it's opening up?
This is positive.
And which one's positive, like in our equation?
Uh, 4.
Yeah, the 4. If this 4 is positive, then it's opening up. So if this is positive, then it's opening up. It's like a happy face, right? It's positive. If this was a negative out front, so like -4, then there would be a negative, so it'd be like a frowny face, opening down. So we know it's opening up. So our graph is going to be something, so it's going to cross at 1 and then 1.5, let's say. So it does something like, this. And what I'm looking for is the vertex. I want to know what that point is right there. So the way we can figure that out is, do you guys remember how to find averages? If I said like, what's the average between, 8 and 5? 8 divided by 5? Yeah.
8 minus 1.
I'm on the right track. What you gotta do is add the two numbers together. So if I want to figure out what the average in the middle between 8 and 5 is, I'm gonna go 8 plus 5 and then divide it by 2.
Why divide it by 2 though?
You divide it by how many terms there are. So if I wanted to find the average between 7, 9, and 12, I'd go 7 plus 9 plus 12 divided by 3. So this is just divided by 2 because there's 2 terms. So we're going to use that concept to find an average. And what we're going to do is, I've got two numbers here, right? I've got 1.5 and I've got 1. What would the average between them give you? Yeah, so let's do it. So let's find, so we go 1 plus 1.5 divided by 2. And that is equal to 1.25. What point of interest is that giving me?
The symmetry?
Yeah, it's giving me the line of symmetry, right? That line, that point right there is 1.25. It's also the x component on my vertex. So this is going to be my line of symmetry. So x is equal to 1.25. But it's also going to be my vertex. I'm going to have 1.25 comma something. I don't know what y is yet. Okay? And this up here, just so you guys are kind of ready, this is going to be our formula for finding our line of symmetry, and our vertex is going to be just adding the two x components up and dividing by 2 to find that average between them. So that you're going to do this all the time, that first one? Okay. Then last thing, we need to find the last one. We got to find where the vertex is on this thing. So we're looking for our y value. Last step we need to do is just go back to our original equation. So original equation was, I said this one, right? Yeah, that one there. That was our original equation. So y is equal to 2x minus 3 bracket x minus 1. Now, I know what the x value is, right? So I know my x value, right? It's 1.25. So if I put 1.25 into place of my x's, what should pop out is a value of y. That's going to be this value of y. So I'm saying when x is equal to this, y should be equal to whatever it is. So if you do that, y is equal to 4, and then instead of an x, I usually put in brackets so I just know it's the thing I'm putting in. It's bracket minus 3, and then 1.25 again, minus 1. So the y value you get if you put that all into your calculator ends up being negative 0.5. So that ends up being our vertex point, right? Negative 0.5. So in general, x value for a vertex is going to be found by going x is equal to r plus s divided by 2. So that's our formula. That's what we did. We just found the average, right? That's all it is, finding an average. And this is also our axis of symmetry. Okay, if we need to find the y-intercept, let's say if something like y is equal to 3x squared plus 4x plus 3. Any idea just from looking at it what the x-intercept would either be? Or the y-intercept, sorry. We kind of played around with that kind of gizmo they were using at the very beginning. You might remember.
Is there just minus 1?
Yeah, the y-intercept is always just this number, just 3.
But,
So it's equal to 3, and I'll just make sure you know why. So we're looking for the y-intercept. We're looking for, let's say, you got a graph, something like that, right? And we're looking for this. That's when x is equal to 0, right? So all we have to do is make x equal to 0. So y is equal to 3 times 0 squared plus 4 times 0. You know, this is equal to 0, that's equal to 0. All I'm left with is y is equal to 3.
yeah.
So that's why this one worked. And then you're saying, what if it was in the other form? So let's say we had something like y is equal to x plus 6. And then let's say 2x minus 3. Same rule applies. We need x to equal 0, right? So what happens if I put 0 in place of x there and 0 in place of x there?
It's 0.
So
Three
in-
times, you mean?
Well, let's kind of just do the whole thing. So we get 0 plus 6.
Oh, it's plus.
Yeah, and then, and then 2 times that x is now a 0, minus 3. So that 0 right there, it's like it's not even there, right? So it's like gone. This 2 times 0 is just 0, right? So that's gone. All I end up with is y is equal to 6 times negative 3. So the y-intercept in this case would be negative 18. So same thing, you just put 0 in place of x to find the y-intercept.
Yeah.
Yeah, that's it. Okay, so we're going to try one where we have a graph. I'm just talking for the video now. So we have a graph. I didn't quite get the top vertex into my window there, but that's okay. What we're going to do is, this is a typical question you guys might get where you can see across is -2 and across is 6. So what we're going to do is we want to find out what the equation of this thing is. So first thing we're going to do is just write down our factored form equation. So y is equal to a, x minus r, and then x minus s. And we're just going to kind of fill in everything we know. Okay, so this one's a good equation because we can see right from the graph that our x-intercepts are at 6 and -2. So I just want to put those in right now. Y is equal to a, we don't know a yet. And a, remember guys, is just that stretch factor. So it's not how much it's going to make our graph, squash or stretch. And then x, and then what am I going to put in for r? So I put in -2?
Yeah.
I'm actually going to put in +2.
Oh, yeah.
It's the opposite, yeah. And then for this one, so 6, but again the opposite. Oh yeah, -6, right? Which is -6, yeah. So we kind of started out with our equation now, right? We're good so far? Okay, so we've got that. Now, the next step that we're going to do is, let's pretend that was at 6, and the graph just kind of sucked. Just want to keep it the same as what's
supposed to be.
It's supposed to be crossing at 6 in the y-intercept. So maybe if you can make your guys' cross at 6, it might make a bit more sense. And the reason why that matters is because that's going to help us figure out, what we want to do is solve for a. We don't know what a is right now. It's kind of our goal in the end here. So we want to figure out what a is so we can put it back in the equation. So we can fill some things in as long as we look at this point when it's crossing at 6. So when it's crossing at 6, I know that y is equal to 6. So I'm going to, instead of a y, I'm going to write 6. Because that's the y value at right there, right? So we're just looking at that one point, right, where it crosses the y-axis. A, we still don't know. Do we know x, though, at that point? It's 0, right? So I can, instead of an x, I can write a 0 in there. And then +2. And then the same thing, so that'd be 0 minus 6. Now we have an equation with only one unknown, just a. That's all we need to solve for now, right? So let's simplify our brackets there. So what we have is 6 is equal to a. 0 plus 2 is just 2. 0 minus 6 is -6. What we have left is 6 is equal to a times -12. I need a on its own. What would I do next? Divide both sides by 12, by -12.
Oh.
Yeah, because I want a on its own, right? So we divide that by -12, those cancel. Divide that by -12. And then I end up with a is equal to -1/2. And this makes sense to me too because it's a negative number. What does that negative number tell me for the a value? Right, that it's a frowny face, right? It's negative, so it's opening down. So we're good there. That does make sense. So we have a negative number for a. Now all we got to do is just put it back into the equation. So we know that that's our value for a. let's just write our equation. Y is equal to, instead of a, I'm gonna write, actually I'll write the whole equation. X minus, or x minus s, not 5. And now instead of an a, I'm gonna write negative 1/2. I'm gonna leave x as it is, because I want y's and x's in my equation, right? But instead of an r, we already figured this one out. So I'm gonna write that as 2 and or minus 6, because those are my x-intercepts. So plus 2, x minus 6. And there, we figured out our equation of that graph.